Hi guys, I'm Engineer HB and welcome back again to Derive. So in today's video, we are going to answer past board exam problems for the Chapter 2 stresses. So nandito pa rin tayo sa Chapter 2 stresses but today on the topic of impact loading. So we already discussed some stresses such as normal and shear. And ayun, I hope na may matutunan tayo dito sa impact loading stresses. So let us start this. So I will read the question first. A 20-pound rigid body is to be dropped at a height of 4 inches above the free end of a 12-inch long, 1-inch diameter vertical steel rod, which is fixed at its opposite end. Determine the shock factor. Okay, so nga pala, I would like to remind you guys that if you want to review first the formulas for the impact loading, so go to the link on the description on the title. So nandun yun sa Facebook page natin, so follow nyo na rin yung Facebook page natin, and of course subscribe to our YouTube channel. Okay, so ang sabi, a 20-pound rigid body is to be dropped at a height of 4 inches above the free end of a 12-inch long, 1-inch diameter vertical steel rod, which is fixed at its opposite end. Determine the shock factor. So first, I will draw the scenario. So lilitan ko lang konti yung mga sulat kasi 2 questions in this slide. So medyo nakain ng space agad to. I cannot separate this one because we need the figures nung mga mauunang maisosolve. So I will draw the situation. So kunyari, ito yung 12-inch long na vertical steel rod. So 12-inch long, ibig sabihin kasing haba ng isang ruler. So this will be a 12-inch long. At ang sabi ay babagsakan ng 20-pound rigid body. So that was medyo mabigat. So almost 8 to 9 kilos. Kunyari, ito yon. So yan si 20-pound rigid body. So babagsak siya at a height of 4 inches. So that was the 20 pounds. And sabi, si vertical steel rod is 1 inch in diameter. Yan, 1 inch diameter. So determine the shock factor. Sabi din pala, which is fixed at its opposite end. So ibig sabihin fixed siya, no? So at its opposite end. Determine the shock factor. So we all know, that the shock factor. So first, I'm going to write the formula for the impact load equivalent. So sinabing impact load equivalent, ito yung letter P mo. P is equal to W multiplied by the 1 plus square root of 1 plus 2 HK over W. So ibig sabihin daw, itong formula na to, itong W is the weight nung babagsak, ibig sabihin siya yung 20 pounds, no? At yung nasa loob naman, which is the H, yun yung height ng babagsakan, which is the 4 inches. No? Si K is springs constant, so it is different, no, on each scenario. So dito, it is the vertical steel rod is fixed at its opposite end. So this is an axial loading. At syempre, meron naman tayo sa mga bending na scenario, which is yung formula ay nandun sa Facebook page natin. So kasi ang purpose lang naman ng video na ito is to review, no, for the board exam. So yung mga formulas to be reviewed on our Facebook page. So itong W ulit, ito yung babagsak ng timbang. Of course, yung H yung height ng babagsakan. K is springs constant. So for this scenario, no, K is equal to A E over L. Now, which is A is the cross-sectional area, is the modulus of elasticity, and L is the length of the rod. So it is the springs constant. Basta ang scenario is fixed at its opposite end. So that's for an axial loading scenario. Okay, so si W ulit, yung weight ng bumagsak. And of course, P is the impact load equivalent. Okay, so once kasi na bumagsak ang isang bagay sa isa pang bagay, So yung W na weight na bumagsak do sa bakal ay may equivalent loading. So hindi porket 20 pounds bumagsak dito, ay 20 pounds na yung equivalent pagdating niya dito. Hindi. That will become a different scenario. So that will become the new load, which is the letter P, and that is called impact load. That is called impact load equivalent. Ayan, so isa-isahin natin. No? So meron na tayong W is equal to 20 pounds. So check na to. Meron na rin tayong W, 20 pounds. Check na yan. So ang H natin, meron na yan. Check na yan. So we're going to solve for the K first, which is the springs constant. So K is area. So since the vertical steel rod is circular, so this is a pi over 4d squared. So ang diameter is 1. Base a problem. So that is inches squared. So I'm going to write the unit na. So familiar na tayo. Para maging familiar na tayo sa unit analysis. So E, the modulus of elasticity. Obviously, kapag walang E, ang sabi lagi 30 times 10 raised to 6 psi or pounds per inches squared. So overall, the length, what is the length? So ang length is 12 inches. So for the unit analysis, of course, cancel si inches squared dito. So ang matitira is pounds per inches. Pounds per inches. So kagaya sa strength of materials sa mga springs constant, that is pounds per inch. Bakit? Springs constant is derived from the ratio of the force over the deflection, which is force is in pounds and deflection in inches. In English unit, kapag metric naman, it is Newton per mm. So our K is to be expected on the pounds per inch unit. So get your calculator, guys. One by one, we're going to write the figures. So pi over 4 times 1 squared times 30 times 10 raised to 6 divide 12. That will become 1,963,495.41 pounds per inch. Okay, so yung strength of materials na ang K is tumutukoy sa stiffness. So ganitong ka-stiff yung ating scenario, 1.9 million pounds do kada inch yung springs constant niya. So ayun, this will become direct substitution na, no? But wait, no? Ang hinahanap is determine, no? Ang sabi, determine the shock factor. So I explained already what is P and W and on this bracket, but here's the thing. No, I forget to tell earlier that this bracket is your shock factor. Kung tutuusin, kung isusulat ko to ng maikse, ang sabi, P is equal to W multiplied by the shock factor. Okay? So ibig sabihin, no, si P, ang impact load equivalent is equal to weight nung babagsak times sa shock factor. Ibig sabihin, si shock factor ang magde-determine how much the 20 pounds here will change. No, so makikita natin mamaya. So pwede na pala natin. So we're not going to include this P and W to get the shock factor. Why? Kasi nga ito na nga yung bracket, no? So ang gagawin na lang natin is shock factor is equal to ayan, 1 plus 2HK divided by W. So that will become 1 plus 2 times 4 inches, which is the H. Our K is in pounds inch, so that will be 1,963,495.41 pounds per inch. So medyo mahaba, no? Kasi nga inabot ng million yung springs constant. So divided by W, no? Sabi ko nga hindi include si W, pero dito kasi nga ito na yung shock factor. Pero syempre si W ay nasa bracket, so weight will be included. So our W is here, 20 pounds. Okay. So unit analysis. So inches cancel dito. Pounds and pounds cancel. So basically shock factor is a unitless kasi nga siya ay factor. So our shock factor will be, so yung K mo kanina wag mo naburahin, times mo yun ng 2, times mo yun ng 4, divided mo yun ng 20, plus 1, square root nun, plus 1, and there you have it. Our shock factor is 887.227 or 882.23. So ibig sabihin, ganyang kalaki yung pinagbago ng bumagsak na 20 pounds nung pumalo siya doon sa vertical steel rod. So doon mo makikita how much, no, in design consideration, how much the shock factor change the 20-pound rigid body na nag-drop doon sa vertical steel rod. Okay? So meron ba tayong 887 pala to? Burahin ko lang. So this is 887. So meron ba tayo? 945.2 sa A. B, A yun. B, 887.23. And the answer is B. Okay, so determine the maximum induced stress in the rod for the second question. So as you can see, guys, this is an eggshell loading. So matic, S is equal to FA. Since the 20-pound rigid body drop perpendicular to the cross section of the vertical steel rod. So this will become an eggshell loading stress. So that will be an F over A lang. So bakit ganun? Ang pangit ng letter A natin. Ayan. Hindi rin gumanda basta hindi pangit. So ano yung F na yan? So ang F natin dyan, of course, yung impact load equivalent natin. Kasi nga, dito, yung W mo, hindi mo siya pwedeng gawing yun yung force mo dito to get the stress. Why? Because andito pa lang si 20 pounds at the 4 inches above. Pero syempre, may impact load equivalent ka nga dito that will deform your vertical steel rod at a certain amount. So, dapat si P yung gagamitin mong value. So, how are we going to get the P? Okay? So, meron tayong formula dito kanina, P, or dito, P is equal to W times shock factor. So, pwede nating sabihin P is equal to W times shock factor. So, ang W natin is 20 pounds. And shock factor natin is 887.23. So, si F ay may unit na pounds. Okay, so mamaya natin siya i-solve. Ipasok na lang natin siya diretso mamaya. So, our A, of course, same dito sa springs constant, that is your cross-sectional area. Kasi nga eggshell loading siya. So that impact load equivalent is perpendicular to the cross section. So that will become 20 times 887.23 divided by pi over 4. So di na kasya yung 4, no? So that will become pi over 4 d squared, so 1 squared. So our maximum induced stress is 20 times 887.23 divided by pi over 4 d squared. So that was 22,593.13 PSI. Kasi ito ay pounds. Pangit talaga pag nagdidikit-dikit ito. Ay, nawala. Yan. Yan. Siyempre gusto ko guys malinaw yung sulat. So this is pounds because it is pounds. And your denominator is square inches since that's a cross-sectional area. So pounds per inches squared. So that is PSI. But the choices is on KSI. So we all know that 1 KSI is 1,000 PSI. So that will become, divide mo ng 1,000. So mabilis ang math, 22.6 KSI or 22.59 KSI. So meron ba tayong 22.6 KSI? So ayun, meron agad na letter A. So answer is letter A. Okay, so nakadalawang item na agad tayo sa impact load stresses. So proceed tayo. So I will read the third question. A round steel bar, 25 mm in diameter, 500 mm long with fixed ends is struck by a weight of 20 Newton at its midpoint at a velocity of 0.75 meters per second. Find the stress due to impact and neglect the weight of the bar. So this is the second case of an impact load kasi meron tayong dalawang case which is ang dalawang case natin ay merong bakal, no, na tinamaan. Kunyari eggshell loading uli. Ito yung body, rigid body na tatama sa isa pang body, drop at a certain height. So that our first case, no, sa impact load na usapin. At ang second case natin is kunyari meron tayong horizontal rod that is fixed on both ends at may pinukol na isang rigid body at a velocity. So kung dito damay si deflection or si what you call that, si height. So dito naman second case si velocity. Basically, first is based on a potential energy kasi drop at a certain height. And the second case is based on a kinetic energy kasi velocity ang pinag-uusapan. So this question is a kinetic energy issue, no? So I will draw first the situation. So ang sabi, a round steel bar 25 mm diameter, 500 mm long with fixed end. So naka-fixed end siya. Ayan, so ibig sabihin parehas fixed ends. Pag sinabing fixed end yan, ito yung nakahang. Maybe a cantilever kapag horizontal ang situation, kapag vertical, that is an axial loading. Pero sabi fixed end, so ibig sabihin parehas fixed ang both ends. So sabi 500 mm long and the cross-sectional area is 25 mm diameter. Sorry kanina, so this sorry for the confusion, this is a H. So kung pag bumagsak, magkakaroon ng certain deflection at yun yung deflection na symbol. Okay. Ayan. So 500 mm long, 25 mm diameter, struck by a weight of 20 newtons. So kanina 20 pounds, ngayon naman 20 newton, kunyari bilog ulit, no, yung hinagis o yung pinatama, no? At its midpoint at a velocity of 0.75 meters per second. So halos 1 metro per segundo ang bilis. Find the stress due to impact, neglect the weight of the bar. So since this is a bending, no? Why? Kasi both ends may tumama, so parang gumanyan. So ang tendency kasi ng vertical natin kagaya sa first problem natin is that is normal, no? Normal load kasi perpendicular to the surface. Pero kapag horizontal naman, syempre, kapag tumama o hinagisan ng kung ano, syempre magbe-bend yan. So that is a bending stress. No? So we all know that S is MC over I for a bending stress. No? Since this is a circular, so madaling makuha yung C niyan, which is C is equal to D over 2, which is 25 divided 2. So that will become 12.5 mm. And the moment of inertia, we all know that the moment of inertia by circular is pi over 64 d raised to 4. So that will become pi divided by 64 times 25 raised to 4. So the unit is mm raised to 4. Kasi d raised to 4. So ulit, pi divided 64 times 25 raised to 4. So that will become 19,174.76 mm raised to 4. Tama, 19,000. So meron na tayong C and I. So we're looking for the M, which is the bending moment. And we all know, no, na kapag fixed end, meron tayong shortcut formula na M is equal to PL over 8. Basta ang itsura niya is ganito. Okay, so ito yung moment, and this is the P. Ibig sabihin si P ay tumama at the midpoint. Sakto sa problem man sabi, binoto raw si 20 Newton weight at its midpoint. So ito yung letter P. So ang mangyari, wala tayong given na P, meaning meron siyang impact load equivalent again, no? Which is on this case, the formula is P P is equal to V times the square root of W times K divided by G, which is K, again, is Spring's constant. No, we all know that the Spring's constant of is fixed and you will see the formula of the other scenarios dun sa Facebook page natin. This is a Spring's constant which is equivalent to 192 EI divided by L cube. Again, K is derived from the formula P or the force divided by the deflection. No? So, pwede rin natin sabihin na Y siya. Kasi di ba meron tayong mga formula na Y is equal to PL cube divided by 48 EI. No? Kapag simple supported, so P divided by PL cube divided by 48 EI. So lalabas, cancel yung P. So that will become 48 EI over L cube. So parang ganito lang yan. At this scenario, this is a fixed end. No, so the constant above is the 192. So that will become 192 EI divided by L cube. So parang di maguluhan, sige, isulat ko na dito. P. So parang nangyari is 48 EI L cube sa simply supported. So cancel na si, wait lang, 48 EI L cube. Ano? PL cube pala, sorry. Nagaya ko yung ano, K. So, ang Y natin sa simply supported is PL cube over 48 EI. So, cancel. Tataas si 48 EI divided by L cube. So, magiging ganun. EI divided by L cube. So, depende sa scenario. So, this is a fixed end. So, maybe the Y of a fixed end is PL cube over 192 EI. So, kaya naging ganito. Of course, G is our acceleration due to gravity. W is yung weight ng pinukol or bumagsak. And of course, V is the velocity. So mamaya na natin ayusin yung unit analysis. Okay, so ano yung E natin? So we're going to get the K first. Ang E natin is modulus of elasticity and we all know that kapag walang given, that will become 30 times 10 raised to 6 PSI. Sa English at sa metric, that is 206,786 megapascal or Newton per mm squared. So our I is 19,174.76 mm raised to 4. And our L is 500 mm. So calculating the K, that will become 192 times 206,786 Newton mm squared times I, which is 19,174.76 mm raised to 4. And our L cube should be 500 cube. And that will become mm cube. So magka-cancel si 4, si square magiging 2. Na force 3 minus 2 magkakaroon ng 1 dito. So the unit of the K will become Newton per millimeter. So that will become, huwag mo naburahin yung I mo kanina, times 206,786 times 192 divided by 500 cube. So that will become 6,090.35 Newton per mm. So medyo umilalim na, no? Pero linawan ko lang ng konti. So 6,090.35 Newton per mm. So meron tayong K. Of course, meron tayong V kanina. W, meron tayo 20 Newton. So this G is 9.81 meter per second squared. That's an acceleration due to gravity. So magkakaroon na tayo ng P. So lalakihan ko lang konti yung sulat for the unit analysis. So P is equal to velocity. So that was 0.75 meters per second times W. So our W is 20 newtons times 6,090.35 Newton per mm. And of course, 9.81 meters per second squared. So how are we going to do this? Meron tayong tatlo. No? May millimeter, may m, may second, may newton. So 4 pala. And we all know that P, kailangan makarating tayo dyan is in pounds or newton kasi that's a force. No? So how we're going to deal with this? Okay, ganito yan guys. So we all know that Newton is equivalent also way back on our physics days of 1 kilogram times meter per second squared. Kasi force is derived on ng mass times acceleration. Burahin ko lang. Mass times acceleration. We all know that mass in kilograms and acceleration in meter per second squared. Kaya nagkaroon tayo ng Newton, no, na unit. So, pwede nating sabihin na, so okay lang ba guys na burahin ko muna yung mga figures in order for us to come up, no, with a unit analysis. So, kanina dito yung W, lagay natin Newton. So, that will become kilogram. Ilang burahin natin sulat na pangit para maintindihan nyo kung i-screenshot nyo man. So, this Newton is for the W or weight. Kilogram meter per second squared. And for the K, that is a Newton per mm. So, another kilogram meter per second squared. Of course, that's an mm. Kasi nga, Newton per mm. Divided by G, which is meters per second squared. Okay, so dito pa lang pwede tayo mag-cancel ng meters per second squared, meter per second squared. So, ibig sabihin, kailangan makancel si M tsaka si mm. And we all know that 1 meter is 1,000 mm. So, saan natin pwedeng ilagay? So, this will become, para maging mm to, we need to multiply this on 1,000. Kasi nga 1,000 mm is 1 meter. So, this canceled. So, ang matitira is kilogram times kilogram per second squared. And that will become meters per second. Square root of kilogram squared divided second squared. So, that will become meters per second times kilograms per second. So, square root ng kilogram squared per second squared is kilograms per second. And that will become kilogram meter. Ulit, burin natin. Pangit ulit sulat. Kilogram meter per second squared. And that will become Newton. Okay. So that's a unit analysis, no? Ibig sabihin, kailangan si weight mo daw is on Newton. So alam mo na yan. So kailangan si K maging Newton per meter, not Newton per mm. Kasi may meters ka na galing dito sa Newton. So dapat naka-Newton per meter ka. Pero kung Newton per mm si K mo, it should be multiplied by 1,000 inside. Pero mamaya natin gawin yon. So, ang gravity should be in meters per second squared. So, alam mo na yan, matik na yan. Pag sinunod mo lang unit analysis na yan, convert mo lahat dyan muna at huwag ka na mag-unit analysis sa dulo. So, everything is on right track. So, burahin ko lang to guys. Yan, rinig na rinig natin ang pagbura. Ayan. So, ayan. So, litan ko lang konti. Ayan. So, that will become W in Newton. So, that is 20. Our K should be in Newton per meter. So, that will be 6,090.35 times 1,000 divided by 9.81. So, our letter P is 20 times 6,090.35 times 1,000 divided by 9.81 square root mo yun times 0.75. So our P is 2,600. Ilang may sumasabit eh. 2,642.8 newtons. Okay, so we are going to solve the M, which is PL over 8. So that will become 2,692. Laking sumasabit, no? 2,692.8 newtons times length, which is 500 mm, divided by 8. So that will become M is equal to 2,642 guys, not 2,692. Ayan. So that will become 2,642.8 times 500 divided 8. So we have a moment of 165,174.46 Newton per mm. Okay, so we are going to solve the stress because we already have the M, the C, and the I, which is here, here, and here. Okay. Okay, so medyo marami. So pwede ko nang burahin yung drawing, guys. So kung napapansin nyo kung napakahaba medyo ng solution, pero this is worth it, no? Hindi lang sa board exam, of course. Pati na rin kung nag-aaral ka pa, still nag-aaral ka pa ng machine design on your college days. So this will become S is equal to 165,174.46. Tama. Sorry, 46. So every decimal is important. So this will become, lagay ko lang unit, Newton mm times C, which is 12.5 mm, and the moment of inertia of 19,174.76 mm raised to 4. So this is mm times mm squared divided by mm4. So may matitira sa ilalim. So that will become Newton per mm squared or megapascal. So we're going to erase this one also. So hindi ko kasi pwedeng burahin ng isa lahat kasi mahalaga pa rin yung detalye ng mga nasulat natin. But of course, you can screenshot. We are on YouTube. You can fast forward or bumalik, no, to take a screenshot. So this will be, wag mo na burahin yung nasolve mo sa calcu, times 12.5 yon, divided by 19,174.76. So that is a 107. Tama ba? S equal to MC over I. So PL over 8. Wait lang. 6,092. 20. By 1981 square root times 0.75. So our P is in Newton times 500 divided 8. 25 mm. So that will be times 1.5. So pi over 64. 64. It's 107.68. Tama. So that is so ang answer is 107.68 megapascals. Okay, so that is the stress due to impact. At ang nakaka-stress doon, guys, wala siya dito sa choices. So, ayun, maybe on the board exam it is void. No? My fault is that I do not check the multiple choice first, pero I ensure you this is the answer. So the answer is 107.68 megapascal. So what is the shock factor? No? So shock factor, we all know that shock factor is, baliktad ulit. Ito muna ang sasabihin ko. We all know that equivalent loading is equal to P is equal to W times shock factor. So our shock factor is the ratio of P and W. And we all know that P is 2,642.8 newtons and W is 20 newtons. So the shock factor is 2642.8 by 20. So that is 132.14. So tingnan nga natin kung may sagot. So ayun. meron tayong 132.2 rito. I ensure you this is the answer. So, okay, so ibig sabihin guys, tama si letter P natin. Why? Kasi may lumabas na sagot dito sa fourth question. But unfortunately, wala sa choices yung 107.68 na stress. No? Because M is MC over I. So ang tama naman yung M natin kanina. So that is a PL over 8. No? Maybe the answer is parang hindi, malapit. So that's not. So tingin ko wala talaga yung sagot. So nangyayari yun, and you can tell the proctor on your board exam that the answer is not on the multiple choice. No, nangyayari yan. So ayun. So pero ano pa rin, nakatapos tayo ng 4 na question, which is worth it naman kasi na isa-isa natin no yung impact load no without reviewing all the topic first by unit analysis lang, and some drawing. So nakatapos tayo ng 4 items for the impact load or stresses due to impact load. So ayun, I hope nakatulong ako and nakapag-review tayo, and salamat sa pagsama sa video na to, and we're going to proceed naman sa another type of stresses, and that is the variable stresses. So see you on our next videos guys. Continue on supporting us, Engineer HB. So andyan yung link ng page natin sa description, and of course subscribe na and share these videos on your classmates and friends. Salamat sa pakikinig. God bless sa inyong review. Bye-bye.